Let's talk about one of the most misunderstood parts of Java, thread scheduling. We're going to bust some myths today, some really common and honestly kind of dangerous assumptions that can lead to some seriously buggy and unpredictable code.
Okay, so let's just jump right in with a question. You've got a super important task. You spin up a thread for it, and you crank its priority all the way up to the max. That means it's guaranteed to run first, right? Well, if you're nodding along, you're going to want to stick around because the real answer might just surprise you. All right, first things first, let's get on the same page. What even is thread scheduling? Well, you can think of it as the traffic cop for your CPU. It's the system that looks at all the threads that are ready to go and decides, okay, you get to run now, and you get to run for this long. But that brings up the million-dollar question. Who is this traffic cop? Is it the Java virtual machine, or is it something else entirely? The best way to think about it is this. The JVM proposes, but the operating system disposes. And this slide really breaks it down. See, the JVM is in charge of its own little world. It manages all the threads and decides which ones are in the runnable state. Basically, which ones are ready and waiting in line. But the final call, the actual decision to put a thread on a CPU core and let it run, that power belongs completely to the operating system. So, knowing that the OS has the last word, it leads to our first big myth. As a Java developer, can you just reach in and force the scheduler to run your threads in the exact order you want? And the answer to that is a big, fat, unambiguous no. You have zero direct control. In fact, the Java specification was written specifically to not make any promises about execution order. Now, what we can do is try to influence it. We can give it hints. We've got methods like setPriority, yielding, or sleeping that basically let us say, hey, scheduler, it would be really great if you did this. But, and this is the most important part, the JVM and the OS are totally free to look at our hint and just ignore it. So let's zoom in on the most popular and definitely most misused of these hints, thread priority. The absolute key here is to get it out of your head that this is a command. It's not. It's just a suggestion. I mean, look at the official definition. It says it all right there. It's a hint about the relative importance of a thread. It's all about trying to nudge the scheduler to say, hey, this one is kind of more important than that one, not to order it around. And in Java, we give this hint with a simple number from 1 to 10. By default, every new thread you create starts out right in the middle at 5, which is norm priority. Fun fact, a new thread just inherits whatever priority its parent thread had, unless you go in and change it yourself. Okay, so this brings us back to that very first question, the big one. If I make one thread a priority 10 and another one a priority 1, is it an absolute guarantee that my priority 10 thread will run to completion before the priority 1 thread even gets a chance? Absolutely not. And I can't stress this enough. This is probably the single most dangerous assumption you can make when writing concurrent code in Java. There are zero guarantees. A higher priority thread might not run first. A lower priority thread might get CPU time before a higher priority one. It's a total toss-up. So here it is, the one-liner I want you to tattoo on your brain. If you forget everything else from this explainer, remember this. Priority is a suggestion, not a command. Nailing this concept is the key to writing concurrent code that doesn't fall apart. Okay, so why? Why is it just a suggestion? Why is it so darn unreliable when you get down to it? Well, it turns out there are some pretty powerful forces at play that can completely override whatever hints we try to give. It really comes down to 3 main things. First, the OS scheduler can just decide to do its own thing. Second, things are wildly different depending on what system you're on. For instance, Windows actually pays pretty close attention to thread priorities. But Linux, it might take all 10 of those Java priority levels and just squash them down into a couple of its own. And finally, the JVM itself is always running its own crazy smart optimizations that can totally change the game. So, if we can't depend on priority or yield or sleep to make sure our code actually works correctly, what are we supposed to do? Let's open up the professional's playbook and see how you write concurrent code that is solid and predictable. The right way, the only way, is to never, ever, ever build your program's correctness on these scheduling hints. Instead, you have to use the real tools of concurrency. We're talking synchronization blocks, the super robust executor framework, or things like fair locks if you really do need a first in, first out kind of ordering. These tools give you guarantees. Priority just gives you hope. So let's wrap all this up by asking one last really important question. Why is Java even built like this? Why all the uncertainty? It might feel like a mistake or a flaw, but it's actually a super critical feature. You see, this non-determinism, this lack of guarantees, it's 100% on purpose. By not forcing the JVM and the OS into a rigid, predictable scheduling model, Java gives them the freedom to make amazing optimizations under the hood. This very flexibility is a huge part of what makes modern systems so fast and efficient. And that brings us to the golden rule, the ultimate takeaway for Java concurrency. A correct, multi-threaded program is one that works no matter what the scheduler decides to do. It must never, under any circumstances, rely on a specific execution order or a thread's priority to function correctly. So I'll just leave you with this final thought. Now that you know thread scheduling is really a world of suggestions and not commands, how is that going to change how you write and, more importantly, how you debug your next multi-threaded application? It's definitely something to think about. Thanks for watching.